So welcome back still. I hope you are doing good. I hope you try to do the exercises that I gave you in the last video. If that was done, you should be having no problems now. Okay, today we shall continue with these subtypes C and D under the integration, under type 3 of integration of fractions. Okay, I'll first add something here. I forgot to add something under here. So let's call this F. If this is F, this will be J, this will be J, this will be H, and this will be I. Okay, let me go back here. I wanted to add this E where we have H of X on the AX plus B to the N. AX plus B to the N. If you are to integrate this, yes, how will you proceed if you are to integrate this? So we have this first one, we have we have this one where H of X, how do you integrate, how do you integrate H of X on AX plus B to the N? Okay, let's without wasting time, let's take this first one. So the C, we are to find how to integrate H of X on the AX plus B dx, where the degree of H of X is greater than or equals to the degree of AX plus B. Okay, the first thing you should note here is this is a polynomial. Be very careful. This is a polynomial. A polynomial is any function of the form, if I will say, it is any function of the form sum of I going from 0 to n of anx to the n. That is simply equals to anx to the n plus an minus 1 x to the n minus 1 plus dot 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 a1x plus a0, anything of this form. If I take for example 3x to the fifth plus let's say 4x cubed plus x squared plus 1, this is a polynomial. The degree of a polynomial is the highest power of x. So the degree, for example, of this polynomial will be what? 5. That's what we call the degree of a polynomial. It is the highest power of the variable of that polynomial. So that was a small emphasis I wanted to do. So let's get into the stuff. So if you are in a situation where you are to integrate H of X on AX plus B dx, where the degree of H of X is greater than or equals to the degree of AX plus B, what you will do, naturally, this is a linear function. What's the highest power of x here? 1. So the degree of this is 1. So the first step to do here, since the degree of H of X is greater than or equals to the degree of AX plus B, the first thing is to proceed to the Euclidean division of H of X by AX plus B. So you proceed to this Euclidean division. You guys are sometimes fond of calling this long division. Okay, so you will do the division of what? H of X by what? AX plus B. Let's say what you have up here is called the quotient, and you have a remainder here. Let's say you had a remainder here. Even if it is 0, it's still a remainder. So after doing this division, you write back this H of X on AX plus B. It will be equals to what? It will be equals to what? The quotient, your quotient plus your remainder all over AX plus B. So the general form is what? What is inside here is called the dividend. The dividend divided by the divisor must always be equals to what? must always be equals to the quotient plus the remainder all over the divisor. So as I said, this is the dividend. This is the dividend. This is called the divisor. This is called the quotient, and this is the remainder. So after writing it in this form, the next step is you proceed to integration, to integration using previously taught techniques. Previously taught techniques. So that's what you do. That's how you integrate such a function. We shall do examples. This I just wanted to illustrate the approach you are to use in integrating such a function. So let's move to the D part. If the integral, the D, it was where is it? The integral of h of x on ax plus b, where the degree of h of x is less than the degree of ax plus b. So integral of h of x all over ax plus b dx, where the degree of h of x is less than the degree of ax plus b. Okay, try to look at this. How can you proceed to the integration of this? I want you to put a pause on the video and try to analyze how you are going to integrate this. Okay, welcome back. So I hope you try to analyze it and you came out with a conclusion. So basically, how are you supposed to integrate this? There's a very important information that's given here. The degree of h of x is less than the degree of ax plus b. When you look at this ax plus b, what's the degree of such a function? If this is a linear function, what's the degree of this? The degree of this is 1. The highest power of x is 1. So if the degree of h of x is less than the degree of ax plus b, it means that the degree of h of x must be less than what? 1. If the degree of h of x is less than 1, it means that the degree of h of x must necessarily be equals to 0. And if the degree of h of x is equals to 0, it means that this term must be what? A constant. It must be a constant. So it must be equals to an r different from 0. Yes, a constant different from 0. Now, if this term is a constant, it means that this is identical to integrating what? A big A all over what? Ax plus b dx. And basically know how to integrate it. We can either integrate it by passing through its formula, which will be, so we will have a times what? 1 all over ax plus b prime ln of the absolute value of what? Ax plus b plus a constant of integration. Or we can still integrate it using this formula, this approach, f prime of f of x dx all over what? F of x. Is that okay? So that's how you proceed. I was not even supposed to give this. I just gave it for me. I just wanted to. My aim here was to see how you are going to analyze this situation and come out with a conclusion. You understand? Because so the conclusion here was that since the degree of this is 1, for the degree, if the degree of this is less than 1, it necessarily means that its degree must be equals to what? 0. Because even if it is minus 1, the degree of this minus 1 is the same as minus 1 times x to the 0. So it necessarily means that the degree of this polynomial must be what? 0. So if its degree is 0, if the degree of that polynomial is 0, it means that it must be a constant. Because if you have a constant r belonging to a belonging to r star, this a is the same as a times, if our variable is x, is the same as a times x to the 0. X to the 0 is 1. You understand what I'm saying? Okay, so that was all about this. Let's look at the last one, which is the integral of this h of x on ax plus b to the n. This is the integral of h of x all over what? Ax plus b to the n dx. I'll give a small precision here. I'll precise that dx, the degree of h of x with the degree of h of x not equals to 0. Yes, I'll precise that, because let me explain why I'm precising it. With the degree of h of x not equals to 0. Look at something. If the degree of h of x is equals to 0, it simply means that our polynomial, it means that the highest power of x is what? 0. So our polynomial is necessarily a constant a belonging to r star. This means that this integral will come back to what? The integral of a all over what? Ax plus b to the n dx. And you know how to integrate this. We saw it already. So that's why I'm putting this condition that the power of h of x must not be equals to 0. Okay, that's why I'm putting that condition. So in this condition, okay, how do you integrate this? To integrate this, what you will simply do is that the first step 1, you express h of x all over ax plus b to the n in partial fractions. You express it in partial fractions. You understand? So the first thing you have to do, you express it in partial fractions. Let me give a small precision also. There can also be a case here where the degree of this h of x, let me see. Wait, let's not start like this. What you have to do here is, the first thing you're going to do is, one, you should first of all verify if either the degree of h of x is greater than or equals to the degree of ax plus b to the n, or if the degree of h of x is less than the degree of ax plus b to the n. Okay, now if you are in this first condition, that the degree of h of x is greater than or equals to the degree of h of x, if the degree of this top is greater than the degree of this, naturally you will do what? You will proceed to long division. You understand? You proceed to long division. Yes. So you will proceed to so as I said, if the degree of h of x is greater than or equals to the degree of ax plus b, you will naturally first of all proceed to what? Long division. And after doing a long division, you will proceed to the integration. But if you are in this case where the degree of h of x is less than the degree of ax plus b, what you do is that you express h of x all over ax plus b to the n in partial fractions, before proceeding before proceeding to integration. So in this situation, I said the first thing, you verify the degree of each of the function. If the degree of h of x is greater than the degree of what? Ax plus b, you first proceed to what you will do is that you proceed to long division before integrating. You first do the long division of h of x by this before integrating. But if the degree of h of x is less than the degree of ax plus b raised to the n, then you express all of this in partial fractions before integrating. So that's all what you have. So if you are given such an integral, the first step, you proceed to the verification of degrees. If the degree of this is greater than equals to the degree of this, you proceed to long division and then you integrate. If the degree of this is strictly less than the degree of this, the whole of this bottom, ax plus b to the n, then you express in partial fraction and you proceed to integration. So that's all what you had to know in this video. In the next coming video, we shall see exercises on how to go about this type of whenever you are given this type of integrals. So see you in the next video.